Okay, let's start with a bit of basics of differentiation. Do you remember how to differentiate ln? 1 over x. What about this one? 1 over x squared plus 1 times with x. I follow what you said. Okay lah, I missed that as well. What about this one? Last one. Yeah. Well, if you forgot about it, remember, firstly we differentiate the sign, and then we copy back, and then we differentiate this one. Okay? So you got yourself 2 cos 2x. That's a differentiation. Easy. Okay, for those who missed it just now, just transfer down whatever in your bracket. One over bracket, and then you diff bracket. In this case, you got yourself 1. This one is the same, 1 over, and then you diff the bracket, which is all the same. 1 over, diff the bracket, 1 over, diff the bracket. That's the very basics. Now, do you remember the concept of what I said just now? Yeah. That integration and differentiation is a reverse process of each other, right? If you differentiate, you integrate, you get the same things back with a plus c. Now, if I ask you integrate 1 over x, what should we get? On x. This is how I remember them. Yes, plus c, thank you. Okay, listen to this very carefully. People outside there might give you a different definition, but this is for me the easiest definition for you to remember how you to get ln. The easiest for you to remember the integration to get ln is when you differentiate the numerator, you differentiate the deno, you get the numerator. Diff deno equals to numerator in terms of x. Diff deno equals to numerator in terms of x. Differentiate x, what do you get? Get 1. Do they have the same x? This one doesn't have x, this one doesn't have x, so it's the same thing. So from here, how do I write down the answers? Just ln deno plus c. What's your deno in this case? X. So ln x plus c. Okay, I'll show you more examples of what we have done just now. So if I were to ask you differentiate for me, integrate for me, something like this, I'll see that it's a fraction. Okay, firstly I'll see it's a fraction. And then if I differentiate the denominator, I get myself 2x. So it will be ln whatever in your denominator plus c. As simple as that. You can go even more. So ex plus 1 dx. If I differentiate the denominator, I get myself ex. So ln ex plus 1, the denominator plus c. And finally, if I differentiate the denominator, I get the same thing as up here. So it becomes ln sine 2x plus c. People outside might be telling you you only get ln when the upper one is 1. But I've shown you here 1, 2x, and ex, and even the 3 go as your numerator, you still get ln. Okay, people outside might tell you differently. They said you only get ln when up here is 1. You say to them wrong. You get ln when you differentiate the denominator, you get the numerator in terms of x. Okay, the formal definition will be f prime x over fx ln fx plus c. That will be the formal definition. Okay. Okay, but of course, formal definition formula, you can hafal, but most people tak hafal. Most people didn't memorize it. You mix up with other formulas. So that's why I prefer the pattern method more. Pattern is easier for you to memorize compared to the formula. Of course, it's more helpful in exams. Well, let's give it a try. Okay, let's start with something simple. Okay, a bit of practice. What about this? Differentiate deno, what do we get? 4. But there's no 4 there, there's only 1 there. Is it still ln? Can someone tell me why is this still ln? Because? Are they the same? They are the same in terms of x. Then it's ln. Understand? 4 and 1, it doesn't matter. 4 and 1 is just a constant. But what about the x? This one has no x, this one has no x. So they are the same in terms of x. Understand? They are same in terms of x. This one has no x, this one has no x. So we shall proceed. But sir, this one has 4. This one doesn't have 4. I can do this. I can times 4 over 4 over here. 4 over 4 is equals to what? 1. So anything I times 1, okay lah, same. It's like you ask your dad for allowance. You said, okay, I'll increase your allowance by times 1. It means nothing. Okay, so I times 4 over 4 outside. And then I can take this one, I can put it in. And I got here. Is it okay? Is the process okay? Now if I differentiate this, I still get 4. So then only I can do what we have done just now. Are you okay? Yeah, I got some people complain that, sir, your jokes we need to think before we can understand. But I think that's how even the meme jokes works nowadays. You have to think for you to get the jokes. Okay, let's be a bit tougher. Maybe I should take a new piece. What about this? If I differentiate here, I get 4. But there's 3 there, so what should we do? I can take the 3 outside. I don't need the 3. And I times with 4 over 4, because I need the 4. 1 of the 4, I put it in. So I get myself 3 over 4. Oopsie. Wrong color. So now only if I differentiate down here, I get things back up here. So 3 over 4. Ln for x plus 1 plus c. Okay? Sorry if it's too fast. You guys okay? Not sure how hard should I increase it. Now what about if I give you something like this? It's too easy. Too easy. All right, class, try this one. Good luck. Don't die. Yeah, I'm increasing one more. Actually, something similar to this one. I'll make things easy for you. Okay, 3 questions. They are struggling. Or they are just acting busy. Yeah, at least they are trying. Okay, the smart one is thinking. Some people are just, very calm, these 2 people. Hey, the look mirror. Okay, so for the first one, if I differentiate here, I get myself 2x. I got the same x, but I just need the 2. So what should I do? I times the 2 over 2. I put one of these two inside. But I don't need the negative, right? So what do? I take it out. So I get myself negative 1 over 2, 2, x squared minus 1. Sorry, I missed the x here. And now if I differentiate here, I get the same as up here. So just negative 1 over 2 ln x squared minus 1 plus c. Oh, I forgot to say, should I do modulus, should I do bracket? The old method is modulus, the old method is bracket, which I learned in the old method. Modulus is fine as well. Okay, don't worry, you will not be penalized by that. But I have to admit, some question I need to solve by modulus method. Some matriculation system. Now what about this one? This one is a bit tricky, because if you differentiate this one, you get yourself negative 2x. How do I add negative? There are two methods on how for you to get the negative. Some people like to do it this way, negative 1, negative 1. Negative 1 over negative 1, so we put this one inside. So becomes 1 over negative 1, negative 2x. So now if you differentiate down here, so it's not much of a problem anymore. Ln 1 minus x squared. 1 over negative 1, what do I get? Negative 1 plus c. But me personally, I'll do it this way. I put negative here, I put negative here. Because negative times negative is positive. So quickly I get myself the answers. Which method is better? Well, I prefer this one. But I understand some people could not get it, they need to do it this way. So which method should you use? Which one you think you can accept and remember in exams, okay? I'm not forcing you. This is another one. We add negative, negative. One inside, one outside. Alright, and the cheeky one. How? Differentiate the denominator. What do you get? 2x ex squared plus 4. Oh my, that's long. What's the difference? Everything here is times 2. So what should you do? I heard two answers. One people said, sir, we times 2 over 2 to the equation, sir. And then we take this 2, we multiply inside. So we should get ourselves 1 over 2. Sorry. You could not do it this way. You should not, yeah. Sorry, your answers is not that correct. The best way is that I can see this one is a multiplication of 2. Yep. It's this way instead. So what I'm doing is I factorize it out. So I factorize the 2 out. And now if I differentiate here, I got the same. Are you okay? You got the same? How many of you forgot plus C? Do you still forget? Some people close the face. Okay.